How's it going? Thanks so much for the introduction, and thanks for being here. My name is Álex Campos. I'm solution engineer at Cloudera, and today I'm sure I'm bringing a very interesting topic about modern data architectures. In this case, data lake. Okay. So let's start with first things first. Okay. So why do we need a lake house? That's the first question I bring to this session. You probably understand, right, the concepts of data warehouse, okay? The main idea is to work with structured data, right? Very well curated data. That means data for reports, for KPIs, and things like that, right? So you need precise data in this case, and also you need to govern that data, right? Some of those, let's say, data warehouse, they are storing very sensitive data, okay? But the world has changed, fortunately, right? Web 2.0 bring more data, more applications, and things like that. And someone came up with the idea that you don't need a house anymore. You need a lake, okay? Data lake, okay? So the idea behind data lake is to store any kind of data, not only structured data, but unstructured data like videos, XML, IoT metrics and things like that. Okay, so it's a new way, a new approach to store data and perform analytics on that data, right? So data lake has been for a while, right? And many companies are using data lake, and they saw the benefits of the data lake from the beginning. They can ingest more data, any type of data, do more things with data that were previously limited by data warehouse. But at the same time, those technologies, they have some kind of, let's say, constraints, right? And the data warehouse, it's about inflexibility, right? Because you need to structure your data. And some of those technologies, they are really expensive, right? Like traditional vendors, okay? And data lake side, we have the data quality because we ingest any type of data, so you put aside the data quality and also the degree of accuracy, right? Because we are not care about these if you're losing some let's say some events, there's no problem, okay? So in the technology, we are really good create new names, you probably know, right? And then we create a new name. Lakehouse, okay? What Lakehouse brings to the world is the best of both technology, the both approaches. First one is data house, so we can have those highly curated and precise and complete data sets, right? For KPIs, for reporting, things like that. But also we can combine with Lakehouse, so we can still have, rich amounts of data, petabytes of data. Some of the clusters on the data lake, they are managed petabytes of data. Okay, I'll talk about some of those, let's say, implementations. Okay, and we can combine so we can have the exploration that is normal, right, and the analytics for analytics capabilities, but also the discovery. Okay, so we can have machine learning and BI. We can have business analytics and data science work and the same data storage in the same system. That's really good. That's really good. That facilitates a lot how the companies are managed, the modern data architecture. Okay. So what are the design goals of the lake house? Okay. First is data freshness. So now I don't need to ingest data first in a data lake and then, let's say, update the data warehouse. We have only one system. So when I have new data, that data is available on the both, let's say, in both formats, for both use, right? Data reliability, that's really important. Keep the data quality in different systems. It's a real challenge for many organizations. So we can definitely have one system that can combine both types of data sets, okay? Advanced analytics, that's really important, right? Many companies are leaving behind the data warehouse, let's say I would say in this way, they are leaving behind the more structured data, the more, let's say, discovery, to start to work with machine learning, when they can have more, let's say, benefits for predictions and things like that, right? So we can have in the same data set both type of users, BI users and data science as well. And talk to your boss and tell that the Lakehouse it's a good TCO, it's a TCO friendly. What that means, it's a cost effective, right? Because I don't need to copy the data one time again, right? So I can only have one copy of the data and serve different use cases. So that's good for your company as well from the, let's say, economic perspective, okay? Move forward, what are the three key principles or pillars of the data lakehouse, okay? Unified data, okay? Now we have only one system that can work with raw data, the data that we just store for the sources, and also with the, let's say, curated or the business data, okay? So we have only one system, one place to put all the data together. It's much easier to apply security as well, right? Because I only need to manage one system, right? The lineage, how the data is moving throughout the different, let's say, steps, right, in the preparation, okay? The second one, it's interesting as well, flexible, okay? Now we can work with more than one engines or frameworks to process the data, to query the data, to analyze the data, okay? Now they can work with things like Spark, Hive, Impala, and on top of the same data. They don't need to have a specific data formats for, for the different, let's say, engines, okay? We it should support mood format like Parquet, CSV, ORC, and all those open source or, let's say, widely used data formats, okay? And also, really important, that probably your company look for this kind of, let's say, projects that you can work with the batch data, the data that comes probably up in the morning, right, at 3 p.m., 4 p.m., but also with stream data, right? So we can definitely create a real-time, data infrastructure for any kind of projects, okay? And last one, really important, Cloudera, it's supporting the open source initiatives for a long time, like Apache Hadoop and others, right, in the data space. So we need to support open data format and open ecosystem, open integrations with different tools. So the data lakehouse should be an open data lakehouse. That's our goal, okay? So let's deep dive in more, let's say, interesting topics about our offering or our solution for Lakehouse, okay? That's the guy that's bringing the solution to Cloudera platform, Iceberg, or Apache Iceberg, okay? So that's another cool name, as you probably know, right? We have really good, great names. So Apache Iceberg, it was, let's say, this project started in Netflix. So probably you can imagine that Netflix has a data problem. They manage petabytes of data. So they came up with the solution to, let's say, facilitate and make easier how they can manage data at that scale, right? At petabytes scale, okay? Especially, and I'll talk about in some slides afterwards about the structure of the data, change data at that speed, okay? Apache Iceberg has support an active open source community, okay? It's Apache Iceberg, under Apache Software Foundation. So this project is evolving a lot. We have a lot of industry adoption. What that means is that more people is understanding and know about about this technology and how they can implement and for different projects, okay? And it's easy to use. You'll see in some slides. It has inference features that everyone will love it, okay? At petabyte scale, okay? I'm not talking about small data. I'm talking about big data, okay? So one of those features is that you don't need, and that's a good news for you, you don't need to learn a new thing or a new language to start using Iceberg. If you know SQL or queries, right, SQL statements, you can start using Iceberg today. at home, okay? It supports SQL statements from Hive, Impala, Spark, and other frameworks, okay? So you can create and manipulate tables, columns, things like that. Run queries, select star from X, okay? Load data, modify data, so you can, you just need this set of instructions to start using Iceberg today, okay? Second, it's what I call a feature that probably Marty McFly and the doctor would like to use, okay? The time travel, back to the future, if you understand the joke, okay? Time travel allows you to query the data in a specific time in the past, for sure, right? So what is the framework is creating continuously snapshots with each data modification, and those snapshots will allow you to query in a specific time. Why that is useful? Because for some of the projects, like I can give you an example, machine learning, the data scientists, they want to see how the attributes will change over time to train those machine learning models. Example, a person that increased the income, a person that changed from a single to married, from child and things like that, right? So that's very interesting for the machine learning perspective. So that feature, the time travel, allows you to do that with all those frameworks you can see, right? Hive, Spark, and Impala, okay? How you can do that? It's really simple, okay? Select star from table, from system data, of a timestamp or a snapshot ID, okay? You can, so simple as that, okay? You can do it in Hive, Impala as SQL, but also in using the Spark API as well, okay? As I said, it's already integrated with the Spark framework, okay? So simple as that. It's really useful and allows you to avoid data copy. Because the companies today are solving this problem by taking a snapshot of the complete data set per day. So that works today, and the next week, and the next month, but imagine 2 years. You'll have a lot of copies of the data set. Okay, that's not cost-friendly, for sure, okay? Compute engine, how we can work with those different engines. As I said, you can work, with those open source guys here, Hive, Impala, Spark, okay? And security is really important in the data space. And the fact that fine-grained access control is really important for all companies, right? Especially in the bank and financial services and things like that, right? So Ranger, Apache Ranger, it's a framework that allows you to add those security layer on top of your data lakehouse or data lake as well, okay? It's already integrated with Hive and Impala, so you don't need to do anything special to do that, to secure your data, okay? So it's completely integrated, so you can secure your lakehouse in the future, okay? So Álex, I have some Hive tables. How can I convert those Hive tables to Iceberg? I want to test those in my organization. That's simple. You just need to run an auto table and change the type, this property, the storage handler, and then that table is converted to Iceberg. Okay, it creates the metadata for you, and from that point you can work with as an Iceberg table. Okay, that's simple. You can also do it in a Spark. Okay, you can import from a Hive table, you create a new one, or you can just convert the current Hive tables as well. So that's simple. Okay, we are facilitate a lot, the onboarding of new use cases in Iceberg. Okay. That's a good one, okay? Partition evolution, okay? In place partition evolution. I will explain that for you. You probably partition your data by day, and by time, right? So it depends on the data volume. It can be month and year. So month, year, okay? That's all, and that works by now, and that's good for everyone. So imagine that, a new requirement arrives, and you need to partition that data for performance, from the performance perspective, to have better, fast query on that data. you need to partition that data by day, okay? So how we can do that today in the data warehouse or lake or data lake world? We need to create a new data set from the previous one and recreate the partition structure, okay? Iceberg is taking care of that, okay? So that's good because we're learning from the mistakes, from the past, right? So we just evolve the partition from, let's say, from month, year to day, month, year. That's all. You don't need to rewrite the data set. You don't need to copy nothing. That's all. It's there for you, okay? So it's, let's say, from the processing cost perspective, it's cheap, right? Because what is changing behind the scenes, it's the metadata, okay? The metadata that keeps all the, the different partitions stable structure of the Iceberg tables, okay? So, and that's common, okay? Many companies, and I have customers that have been trying to do that, right? Because the data today is changing a lot. Not only more data is coming, but also the data structure as well, okay? So that's a good feature as well, okay? How we can do that? We just do this, okay? Outer table, table T, okay? Set partition specific by our timestamp, okay? And then it will reorganize the metadata for you, and you can start query and those new, let's say, partition configuration you did, okay? Schema evolution, so that's not new. You can, create you can create columns. You can drop columns. You can rename. You can update, in this case, okay, the type of column, okay. You can also reorder the column. So you can do whatever what is necessary, right, to manage your data, okay. What you can see here in this, let's say, graph is how the metadata is moving, okay, in the different, with each, let's say, update and change in the structure, okay? You can see a video and can understand even more how Iceberg is doing behind the scenes, okay? So those are more the, let's say, technical features that I'm bringing for you, okay? But in Cloudera, we see that the Lakehouse is one part of the multifunction analytics, okay? So it helps to organize and maintain the data, for sure, but you also need more things, right? You need analytics capabilities or service, right? For stream data, for data warehouse, for things like data engineering, right? To ETL, do some ETL jobs on top of our data, right? So this type of things also complements the Lakehouse, let's say, infrastructure, okay? A shared platform that allows you to do any kind of operations. Also really important that we see, and in Cloudera that we propose this hybrid data cloud, is that it can be in any cloud and any storage. It can be in your data center if you need, right, for, I don't know, compliance, from the compliance perspective, but also in the cloud, okay? It can be in the public cloud for sure, and you can leverage those services, okay? It's enterprise ready, okay? Security is really important, as I mentioned, okay? It is part of the, what do we call, the, a hybrid platform, okay? The Open Data Lakehouse enables by the unified data fabric, right? And also that is working with and integrate with those different services, analytics service, okay? And that also enables you to work in this data mesh, approach, right? To work in this, let's say, keep the ownership of the data to each department, to each, people in the company, okay? Thanks so much for your time. If you have questions, we have a booth here, so reach out to me and we can have a talk, okay? Thanks so much.